what do you mean by the term steady state error of a control system? Well, my name is Rishi Remju and welcome to the Backbench Engineering Community, where I make engineering easy for you. So, let us ask ourselves that obvious question, what do you actually mean by the term steady state error of a control system? Well, let's find out. So, let us consider this particular control system. So here, there is a negative feedback that is provided over here. And the forward loop gain is given as G of S and the negative loop gain is given as H of S. So here, what we observe is that over here, there will be an error signal E of S. So this error signal E of S is obtained as the difference between this signal R of S and whatever that comes as a negative feedback over here. So let us just simply write that down. So this error signal E of S is equal to this particular signal R of S, which is the input signal, subtracted by whatever that comes out over here. So here what we observe is that here we have C of S, and when this C of S passes through this, we would get over here C of S into H of S. So therefore, this C of S into H of S would be subtracted over here. So here we would have R of S minus C of S into H of S. Let us take this as equation number 1. But here we can observe that this particular C of S is simply the multiplication of this E of S into G of S. That is, when this E of S is multiplied by G of S, this is what we observe as C of S. So here, C of S is equal to E of S multiplied by G of S. Let us now substitute this over here in this particular equation. So we would now get E of S is equal to R of S minus, here C of S is E of S into G of S. So this becomes E of S into G of S, whole multiplied by H of S. So here we have two E of S terms. So let us take this particular term towards the left hand side. So here we would get E of S multiplied by 1 plus G of S into H of S is equal to R of S. So therefore, this particular error signal can be obtained as E of S is equal to R of S divided by 1 plus G of S into H of S. So this is the value of the error that is present inside this particular control system. So that just gives you an idea of what the error is. So now the steady state error is simply the value of this particular error signal when limit t tends to infinite. As simple as that, guys. That is what is simply referred to as steady state error. So for t to be tending to infinity, here this must be converted into time domain. So here, because we have E of S, now E of t can be obtained as E of t is equal to the inverse Laplace transform of this particular E of S. Therefore, the steady state error ESS is equal to limit t tends to infinite, this particular error E of t. This is simply what you refer to as the steady state error of a particular control system. So now, applying final value theorem, we would get this limit t tends to infinite E of t as this is equal to E of infinite, which is equal to S into E of S, where limit S tends to 0. So this is the value of the steady state error in the case of a particular control system. As simple as that, guys. That is, the steady state error ESS is equal to limit S tends to 0, S into E of S. This is the value of the steady state error in the case of a control system. So this steady state error can be used for the purpose of measuring the system accuracy and things of that sort. That is why we use steady state error. So now let us assume that we are giving a unit step signal as the input here. Let us give a unit step signal as the input over here. Then if we are giving a unit step signal as the input, then R of S is equal to 1 divided by S. So let us substitute this over here. So now ESS would become ESS is equal to limit S tends to 0 S into E of S. E of S is this term, so which is R of S divided by 1 plus G of S into H of S. So here R of S is 1 divided by S, so this becomes 1 divided by S divided by 1 plus G of S into H of S. So 1 plus 1 by ST. So therefore this would become equal to 0. So this is the steady state error when we give a unit step signal as the input. Next, let us see what happens when we give a unit ramp signal as the input. So if when we give a unit ramp signal as input, R of S is given as R of S is equal to 1 divided by S squared. So now substituting this over here in this particular equation, we would now get the steady state error ESS is equal to limit S tends to 0 S into, here E of S is this particular term, R of S divided by 1 plus G into H, but R of S here is 1 by S squared, so this becomes 1 by S squared divided by 1 plus 1 by ST. So therefore this would now be equal to T. So therefore these thus are the steady state errors in the case of a unit step signal and the unit ramp signal. As simple as that, guys. There's nothing more to it. As simple as that. So I hope you guys now have a clear understanding of what you refer to as steady state error of a control system. And if you guys found this video informative, please do hit the like button and join this community by hitting that subscribe button. We'll be discussing about the further topics in the upcoming videos. So stay tuned, stay subscribed. Until next time, I'll see you guys in the next video. Thank you.